Welcome students to another in our Investigating Science series. Today we're in grade 8 and we're looking at physical and chemical changes. We will be guided by these questions. What are physical and chemical changes? How can we determine if a change is physical or chemical? Now, what is the result of a physical or a chemical change? Before we get into this discussion, let us review a few things about reversible changes. Now, from grade 6, you would have encountered the concept of a reversible and an irreversible change. So consider, for instance, melting ice. When ice melts, it has changed from a solid to a liquid, right? Now, can we get back the ice? Yes. How could we get back the ice? We would simply need to freeze the water to get back the ice. So that represents a reversible change. Now, if I should strike a match, for instance, right, the match would quickly burn. Now, could I get back the original match? Probably not, right? Just as frying an egg or burning paper, these are examples of irreversible changes. And in these examples, new substances are formed. So, in essence, physical changes can be reversed while chemical changes are irreversible. So, what are we going to investigate today? We are going to be investigating how to carry out or to demonstrate a physical or chemical change. There are some examples shown on your screen. Melting butter, for instance, is a physical change, whereas burning wood, or in this case, burning a piece of match, as demonstrated here, would represent a chemical change. All right, so let's get into this investigation. Or what will we need for this investigation? We will need iron filings. So they are very tiny particles, tiny pieces of iron, almost like a powder we have in this container. We're using our hot plate to supply heat. We have sulfur. You would have heard of persons using sulfur for, what's that? Something to do with your face. Yes? Can't remember the name of that particular condition, but we can use sulfur in that regard. So I have some samples of sulfur, iron filings, and we're going to see what happens when we mix these, what sort of change will occur. Okay, so let's see the steps that we will take. So I'm going to take a sample of our sulfur. Note, in any experiment, whatever you use, you note your observations. What is the color of the sulfur? Please note that. So I'm going to add some of this sulfur to a small beaker. And I'm also going to add some iron filings. As I said, it's iron in a very powdery form. Yes, that's iron filings, right? And if I should mix them, what do you think will happen when I mix the two? So I'm mixing the two, right? Let us look closely. When I mix them, can you still see the sulfur separate from the iron? If you look, you can still see some yellow substance in this container, and you can also see the brownish looking color of the iron filings. Now, this would represent what we call a mixture. So I'm going to pour this out into a Petri dish, yes, and you can see the samples of the iron and the sulfur mixed together. So the components are easily seen. Now, how could I separate these components? If I wanted to get back the sulfur and the iron, to separate them, could we separate them? What do you think? How could we separate them? All right, I'll leave you to think about that for a while. We're also going to have another container where we're going to mix again these two substances, but this time we're going to try to heat it. So again, we'll pour some into our small beaker, and we will add our iron filings. And again, we will mix the two, and we're going to add this to our evaporating dish. So this would represent our evaporating dish. Go there. So we're adding, and we're adding to this. Please note what's happening. Can you see what's happening when I'm heating this mixture of the iron? Wow. Do you see that? The iron and the sulfur, and if you were in the studio with me, you could actually smell what's happening here, right? So it has a particular odor, very strong. So the iron and the sulfur are reacting because of the heat. Now we're going to compare what these substances look like after it is heated and compare that to the original substance that we mixed. All right, and you can see that it has basically taken on, it's melting, and of course we can see a flame almost that is generated. So let's turn this off and allow it to cool. All right, you can see what's happening there. So while we wait on it to cool, let us go back to our original mixture of the iron and the sulfur. We asked, could we separate those components? And it is possible to separate them. If we use a magnet, yes, a magnet, we should be able to separate the components of that mixture. Let us demonstrate. Let us clear the way so you can see it clearly. What happens when I try to separate? And if you're looking, you will see something interesting happening here. The magnet is picking up all the iron from the mixture, all right? And you can see it on the magnet. Do you see that? So what we're seeing here is that we can separate the sulfur mixed with the iron filings, all right? So when we use our magnet, we can take out the iron, and of course, eventually, we would have taken out all the iron and the sulfur would be left. Let's see if we can take some more. All right. So that is a way that we could separate these components. Now, the fact that we could separate them, that means that we could get back our original product, right? Then this would represent what we call a physical change because we can get back our original materials. Now, let's look at the sulfur and the iron that was heated and compare it to the original mixture. If we notice here, we'll see that the mixture, well, of course, we saw that it basically melted. There was a flame produced, a yellow-looking flame. And now we have a very black-looking substance that has an odor that is totally different in composition to what we have in this container. So because we cannot get our original substances from this heated mixture, we would call that a chemical change. Let's see what are the questions that we need to answer. So, we're asking what type of change occurred when the iron filings and the sulfur were mixed. We are calling this a physical change. Why? It is reversible. We can get back the iron by using a magnet. And that is how we were able to separate the components of that mixture. When we heated the iron filings and sulfur, we noted that they melted and a new substance was formed. How we know it's a new substance? It had different properties or characteristics from the original mixture that we had. And so this represents what type of change? This represents a chemical change. And so we can make some conclusions from this. Right? Let's see our conclusions. Certainly, when we mixed the two, because no new substance was formed, it was just a mixture, we're saying that represented a physical change. And therefore, we can conclude that just mixing two substances together, right, can form mixtures which are made from physical changes. So mixtures are formed from physical changes. Now, when we combined the two in this case and heated it, we got a new substance, and that substance is called a compound. We actually formed iron sulfide. So iron plus sulfur, when heated, formed iron sulfide, and that is a compound. And so compounds are formed from chemical changes. I hope you learned a lot today. And of course, do not try this at home. This should only be done under the supervision of your teacher. We will continue to investigate some more interesting science concepts happening all around you. See you next time.